Welcome to the deep dive. Today we're digging into something pretty interesting, the connection between rain and solar panels, specifically right here in Charlotte, North Carolina. Our mission really is to figure out how Charlotte's, average 43 inches of rain a year? How that actually affects solar panels, the good, the bad, and maybe the unexpected.
Exactly. It's easy to just think solar equals sun. Simple as that. But rain, it's complicated. It brings real challenges, sure, but also some genuinely surprising pluses.
Okay, let's unpack that. We all picture bright sunshine powering these things. So Charlotte gets a rainy day, clouds roll in. What happens to the actual energy output, like right then?
Well, the immediate thing is cloud cover, obviously. It scatters the sunlight, right?
Hmm.
Makes it less intense hitting the panel. We've seen studies showing that even light cloud cover can drop output by, say, 10 to 25%.
Okay.
And heavy overcast skies. That can cut production maybe even up to 50%. There was one test in a humid area like Charlotte where power dropped something like 93% during really heavy rain compared to a clear day.
Wow, 93%. That's huge.
It is. So, persistent cloudiness here means solar projects really need to factor that variability in, not just bank on peak sunshine hours.
Right, so less sun equals less power. That's the clear downside. But you mentioned benefits earlier, which sounds kind of counterintuitive. What are these less obvious advantages of rain?
And that brings us to a really key point.
Yeah.
Can rain actually help panels? And the answer is absolutely yes. See, solar panels, they lose efficiency when they get hot. It's about maybe zero point 0.3 to 0.5% less efficient for every degree Celsius hotter they get.
Hmm.
And here in Charlotte, summers get hot, often over 30 Celsius,
Yeah.
90 Fahrenheit.
Oh, yeah.
So when it rains, it cools those panels down, and that actually fights those heat losses. Some experiments in hot climates showed panels cooled by rain were running like 5 to 8% more efficiently than they would have otherwise.
5 to 8% just from the cooling effect of rain.
Exactly. So in a place like Charlotte, especially with urban heat islands maybe making things warmer, the cooling isn't just a small thing. It's actively helping performance, not just a negative.
Okay, so cooling is a definite plus.
Yeah.
What about other things, like Charlotte's infamous spring pollen, that yellow coating everywhere? Must be terrible for panels. Does the rain wash that stuff off?
Yeah, that's a great question. Rain definitely acts as a kind of natural cleaning system. It's pretty good at washing off regular dust, especially after a dry spell. That alone can boost efficiency maybe 8 to 15%.
Okay, that's significant.
It is. But, and this is the important part, it's not a perfect fix. That spring pollen you mentioned, it can be really sticky, reduce light getting through by up to 15% sometimes. And while rain washes some away, studies, I think from NREL, show that even after rain, panel performance might still be 5, maybe 11% lower than before the pollen hit.
Ah, so it helps but doesn't get it all.
Exactly. Manual cleaning is often still necessary, especially for things like pollen or bird droppings. A good scrub can outperform just rain cleaning by maybe 12%. Plus, sometimes frequent rain can leave mineral deposits behind, like hard water stains.
Right, right. Okay, so we've got efficiency hits from clouds, benefits from cooling, and this sort of partial cleaning effect. Taking all that into account, how is the technology changing? Are panels getting better at handling rain?
Yes, definitely. If we look at the bigger picture, there's some really smart adaptations happening. I mean, the basic thing is just tilting the panels correctly, usually around 33 to 38 degrees here, which helps water just run off.
Makes sense.
But beyond that, there are these hydrophobic nanocoatings, basically super slippery surfaces that can cut down how often you need to manually clean by maybe 40%.
Wow.
And even cooler, I think, are these things called bifacial solar panels. They actually absorb light from both sides.
Both sides. How does that help with rain?
Well, there's a pilot project looking at using them on white, reflective rooftops. The idea is when it rains and the ground or roof gets wet, it becomes more reflective. These panels can capture that reflected sunlight bouncing up off the wet surface, potentially boosting output by 10 or even 20% during overcast, rainy conditions.
That's incredible, getting power from light bouncing off puddles.
Pretty much. And then there's AI, artificial intelligence being used for predictive maintenance. It helps figure out the best times to clean panels, knowing when the rain just isn't cutting it.
Okay, that's fascinating tech. So pulling it all together, what does this mean for someone actually living in Charlotte, thinking about getting solar panels? How does this play out day to day?
That's the crucial question, right? Despite these rainy periods, Charlotte still gets, around 213 sunny days a year on average.
Yeah.
That means the payback period for a home system is still pretty good, typically around 6 to 8 years.
Okay, that's reasonable.
And think about battery storage. There was that big thunderstorm back in May 2024. Having batteries meant some homes with solar kept the lights on during the outage.
Right, the resilience factor.
Exactly. And after that storm passed, analysis showed the panels cleaned by that heavy rain were producing about 14% more energy on the sunny days that followed compared to panels still dirty.
Ah, so you see the cleaning effect in action there.
You do. And even though some HOAs can be tricky, there are federal and local incentives that really help make solar affordable and practical here, despite our uh, sometimes wet weather.
Those real-world examples definitely help frame it. So, wrapping this up, it seems like the takeaway for folks considering solar in Charlotte isn't just about the sun. It's this kind of dual reality, isn't it? You get these temporary dips when it's raining, but you also get these real long-term boosts from cooling and some natural cleaning. And investing in newer tech, like those coatings, batteries, maybe even those bifacial panels, seems like the smart way to maximize things here.
That sums it up well. It really highlights how complex the interaction is. Maybe that leads to a final thought for you, the listener. As our climate continues to change, potentially bringing more variable rainfall, and as we keep innovating, maybe even integrating solar panels with how we manage stormwater, what other surprising connections, what other synergies might we find between our energy systems and the natural world all around us? Something to think about.